In this session, we will discuss effect of negative feedback on input resistance and output resistance. Now, in the last session, we have discussed there are 4 types of feedbacks are there: voltage series feedback, voltage shunt feedback, current series feedback, and current shunt feedback. So now in this today we will discuss how this negative feedback affects on voltage series on input resistance and output resistance. Now let me draw the block diagram for this. Now this is the amplifier. Now here I am denoting with a short form A. Amplifier gain is A and feedback network beta. Now here voltage series means in the last lecture in the topology itself I have explained that voltage is the output side, that is sampling, and series is the input side, mixing. So now output I want sampling is voltage, means at the output I have to make this shunt connection so that I can get the same voltage over here. Now this is the V0, here the voltage is V0 and the load is RL resistor. Now the same voltage I should get here, that's why I made here shunt connection. Now input side series, here I am taking the series connection. Now in a series, which supply I have to connect? So voltage supply I have to connect. Why I need to take the voltage source? In a series, voltage can be added or subtracted, but currents are same, that's why I have to take the voltage source. Now here this parameter is Vi, now here we are getting the Vf. Now what is A? Gain of this amplifier is output to the ratio of output to the input. Output is what? V0. And what is input? Vin. Now coming to the beta, feedback network, beta is equal to what? Output to the input. Here in the for this feedback network, output is Vf and input is V0. Now these two expressions we got from this block diagram. Now for this I need to draw the equivalent diagram. Now for amplifier, how to draw the diagram? Amplifier input I am taking. So for any amplifier, if it is a voltage input, if you are taking the voltage source or current source, for any source we have to draw the equivalent diagram. For the amplifier input side is only resistor, and this resistor is nothing but Ri. This is the amplifier input resistance. Now coming to the output side, here we are taking the voltage as a sample. So voltage we are taking, so output side you have to take the voltage source in series with the resistor. Voltage source, dependent voltage source in series with the, now here the, what is in series with the resistor. Now this resistor is nothing but R0 resistor. Now complete this circuit is called this is the amplifier. So this is the equivalent diagram for the amplifier. So input side if you are taking the voltage source or current source, you have to represent only with the resistor, but output side if you are taking the voltage, then you have to represent with the voltage source in series with the resistor. If you taking the output as a current, then at that time you have to represent the dependent current source in parallel with the resistor. Now this is about the block diagram of the amplifier. Now for this Vs we need to give at the input side. Now here input side Vs we have to connect. So Vs, now this is nothing but plus minus. Now here I am taking the feedback voltage minus and plus, because this is a negative feedback. So here whatever the feedback we are giving, that is subtracted from the source. So now here this is the Vi, this is Vi, and this is a single loop. Current flowing in this loop I can take it as I. I am taking it as a I, and output side I am connecting the load resistor RL. Load resistor RL, and across the RL what is the voltage? V0 voltage. Now this is the equivalent diagram for the voltage series feedback. Now for this we need to calculate the input resistance and output resistance. Means after applying the feedback, what happens? Now without applying the feedback, amplifier input resistance is Ri. Output resistance is R0. So in a volt, now input is voltage and output is also voltage. In the beginning, the first class I have explained that this is a voltage amplifier. In the voltage amplifier, input resistance should be more so that it can take complete voltage from the voltage source and it will amplify, and after the amplification, now it has to transfer all the voltage to the load. For that the internal resistance R0 should be very, very low. Now Ra should be very high and R0 should be low for the voltage amplifier. Now with the feedback, what happens we will see now. Now to calculate, now from here, from this point, if I look into the amplifier, then Ra is equal to, I can write it as Vi divided by I. Now the voltage in this loop is, current in this loop is I. So that's why Vi by I. Now if I am observing from this point, means what? After the feedback, if I am observing, the resistance is called as a RIF. So with the feedback, what is the resistance? Now if I am looking from this, voltage is Vs and current is I. Now if I write the expression for Vi, now this is a negative feedback, Vi is equal to, what can we write? Vi is equal to, we can write it as Vs minus Vf. Why? Because the feedback, whatever the feedback we are applying, that is subtracted from the input feedback, or it is out of phase with the input. That's why we get the minus value. Now here Vs minus Vf. Now in this expression, what can we write? Vf is equal to, Vf is nothing but, from this expression we can write Vf is equal to, Vi is equal to Vs minus beta times V naught. So Vf is nothing but what? This is beta times V naught. Now again V naught, from this expression what can we write? V naught is equal to, so Vi is equal to Vs minus A beta V naught. So now in this, V naught is equal to Vi. So beta times A beta Vi. Now write all Vi terms together and take out Vi, then you will get 1 plus A beta is equal to Vs. Now substitute the from Vs is equal to from this expression and Vi is equal to from this expression. Then Vi is equal to, what can we write? Ri into I into 1 plus A beta is equal to, Vs is equal to, what can we write? RIF into I. Both sides cancel the I and you will get RIF is equal to what you are getting? Ri into 1 plus A beta. With this what we understood? Now with the feedback, the input resistance is increased by 1 plus A beta times. So in the voltage amplifier, the input resistance should be more. With the negative feedback, what happens? Further it increased. So this is the effect of negative feedback at the input resistance. Now similarly, we need to calculate the output resistance. Now for that, now here to calculate output resistance, what we need to do? Open the RL value. Now here I am opening, and from here we have to measure. That is nothing but R naught F. R naught F is equal to, what can we write? I naught. Now this is the I naught current. So V naught divided by I naught. So now here and make the input source 0. So condition number 1 is to calculate the output resistance. Output resistance R naught F is R naught F. How to calculate? Condition number 1 is make RL is equal to infinite. Means what? Open the output terminals where we are measuring the output resistance. And condition number 2 is input supply you make it to 0. If it is a voltage source, you short it. If it is a current source, you open it. Now this is the, now here if I am shorting the input source, then this is the diagram for the to calculate the output resistance. Now from this, if I take the input loop, so what can I write? Vi is equal to what? Vs minus Vf, right? Now where Vs is equal to 0. Vs is equal to 0, thereby we will get Vi is equal to minus Vf. Then what can we write? Vf is equal to minus beta times V naught. So Vs is equal to, we can write beta V naught. So now from the output loop, now this is a input side we have taken. Now from the output loop, if I wanted to calculate this V naught by I naught, then if I apply the KVL at the output loop, or if I wanted to write the expression for the I naught, now I naught is, I naught direction is in this direction, means what? Current is leaving from the V naught. So we have to write the expression V naught minus, now this dependent voltage source name is A into, it is depending on the input voltage. Now here what is the input parameter? Vi. So A into Vi. So now here how can I write the expression for the I naught? So this is one drop, this is one more drop, one more potential. So I am taking the potential difference of these two, V naught minus A into Vi divided by R naught. This is the expression for the output current. Now from in this, if I am writing Vi is equal to, now Vi is equal to, what can we write? Minus beta V naught. So now here I naught is equal to V naught minus A minus beta V naught. divided by R naught. If I rewrite this expression, I'll get I naught is equal to V naught plus A beta V naught divided by R naught. Now I'm taking V naught common, and I'm writing the expression in this term, in this manner. Then I will get V naught divided by I naught is equal to R naught divided by 1 plus A beta. Now with this negative feedback, what happened? Now this V naught divided by R naught is nothing but what? R naught F. So now R naught F is equal to what? R naught divided by 1 plus A beta. Now with this, what we understood? Output resistance is reduced by 1 plus A beta times. Now in the voltage amplifier, how should be the output voltage, output resistance? It should be minimum, so that it should not drop any voltage. The complete voltage should transfer to the load. Now with the negative feedback, what happened? Further the output voltage reduced. Now this is the effect of negative feedback on both the resistor, input and output resistor, in the case of voltage series feedback. Now in the next lecture, in the next slide, we will see the voltage shunt feedback. Now here same, again I will take the same amplifier, and here it is a feedback network. Now output is voltage. Output is voltage means what? Again output side I have to take shunt connection, input also shunt. So input I am taking the shunt connection. Now tell me, if I am taking the shunt connection, which source I have to use? In the shunt only currents can be added. So